Alright, welcome back to Math 1910. We're going into Chapter 2, Section 3. We're going to go over the product rule and the quotient rule. Alright, and we should be able to find the derivatives of those. And then we're going to take a look at a few derivatives of some of the trig functions as well. So, when we go through this, I just want you to know I'm going to do a lot more extensive examples in class. So make sure that you're watching the live stream as well. This is maybe to help you, out at home or things like that. So, first thing we need to understand is the product rule. So if we're going to take the derivative of two functions that are being multiplied together, so we have an f of x times a g of x. Okay, the best way to remember this is we take the first times the derivative of the second plus the second times the derivative of the first. So that's what that means down there when we have f of x times g prime of x plus g of x times f prime of x. So just remember that's the first function times the derivative of the second function plus the second function times the derivative of the first function. So let's kind of see this one in action here as we take a look at how this works when we have a whole string. Okay, so if we have one where there's three functions multiplied together, okay, it works out the same way. Alright, so if we have f of x times g of x times h of x, we need to take the derivative of that function. Okay, it's going to be f prime of x times g of x times h of x plus f of x times g prime of x times h of x plus f of x times g of x times h prime of x. So essentially you have to take the derivative of each function and multiply by the other two functions and then sum them together. So you can kind of see how it works. If we have the derivative of y equals x squared times sine of x times cosine of x, all right, we have to take the derivative of f of x first. So f of x would represent the x squared, g of x would represent the sine of x, and cosine represents h of x, if we were looking at the grand scheme of things. So it would be 2x, which is the derivative of f of x, times sine of x, cosine of x, those are the original functions, plus, okay, the original function x squared times cosine of x, which is the derivative of sine of x, and then times cosine of x, that was the original h of x, plus x squared times sine of x, and then we take the derivative of the last function there, cosine of x. The derivative of cosine of x is minus the sine of x. Okay, and then we combine all the like terms, so we end up with 2x sine x cosine of x plus x squared times the quantity of cosine squared x minus sine squared x. Be careful that doesn't reduce to 1 because it's cosine squared plus it's sine squared plus cosine squared or cosine squared plus sine squared that it reduces to 1. Not that scenario. Okay. So the derivative of a product of two functions is not given by the product of the derivatives of the two functions. So you got to understand that you must use the product rule. You must. All right. It doesn't mean to find the products and take the two derivatives and multiply. All right. So let's do a couple examples here that we're going to go through. So if we have the function h of x equals 3x squared minus 2x squared times the quantity of 5 plus 4x. Okay, we're going to deem this as two functions. The first function, the 3x minus 2x squared, that's our f of x, and the 5 plus 4x is our g of x. Okay, so you're going to take first times the derivative of the second plus second times the derivative of the first. So you can kind of see how that's laid out here. First, and then we're going to take it times the derivative of the second. The second term is 5 plus 4x. Plus the second term, which is 5 plus 4x, times the derivative of the first term, which is 3x minus 2x squared. Okay, so this is the formality of laying it out. So see how we're writing h prime of x, okay, and then we're saying d dx, that's the derivative with respect to x of that entire quantity. Okay, so let's do that now. And when we take the derivatives, all right, we have our first, which is 3x minus 2x squared, times the derivative of the second. The derivative of 5 is 0. The derivative of 4x is 4, so we're just multiplying by 4 there. Plus the second term, 5 plus 4x, times the derivative of the last term, right? The derivative of 3x is 3, and the derivative of 2x squared is 4x, so it's 3 minus 4x. Then we can simplify. So we have to FOIL out that second term. We have to distribute 4 to the first term. So there's where we get 12x minus 8x squared. Okay, plus, then we have to FOIL that second term. So we're going to take the quantity of 5 plus 4x times the quantity of 3 minus 4x. FOIL that out, or binomial multiplication, or the box method, whatever you learned, right? For that, we end up with 15 minus 8x minus 16x squared. So then we combine like terms, all right? So our final answer for this derivative is negative 24x squared plus 4x plus 15. Okay, so make sure that we are using the product rule. So you need to identify what's the first term, what's the second term, or what's the first equation, what's the second equation when we do this. Let's do another example here, all right? We have y equals 3x squared sine of x. So we can obviously see that our first term is 3x squared, our second term is sine x squared, or sine x, sorry. You need to be able to, distinctly identify the two terms. So when we do that, we're going to take, y prime is going to be 3x squared, the first term, times the derivative of the second term. So we're going to take the derivative of sine of x, plus the second term, sine of x, times the derivative of the first term, 3x squared. So when we do that, we're going to get 3x squared. The derivative of sine of x is cosine of x, plus sine of x times the derivative of 3x squared is 6x. Okay. Then we rewrite the function. I always write the multipliers to the trig function in front. So all I did here is really just rewrite it. So it's 3x squared times cosine of x plus 6x sine of x. And then we want to simplify this down so we can factor a 3x out of both functions. Okay. So when we factor out a 3x, we're left with 3x times the quantity of x cosine of x plus 2 sine of x as we go through this. Okay, let's take a look at this example. Now notice this one's a bit longer, okay, because we have minus a second term here. So I've highlighted, a few different terms here. We're going to take the product rule of 2x cosine of x, and then we're going to take the product rule of 2 sine of x. Okay, so that's why I've highlighted one in blue and one in red. So we're going to start out with kind of 4 terms here, okay? So when we do y prime, we're going to take 2x times the derivative of cosine of x, which is minus sine of x, plus cosine of x times 2. So we've handled that 2x cosine of x, and we've used the product rule there. We've used first times the derivative of the second, plus the second times the derivative of the first. Now we're going to look at the next term here, 2 sine of x. So we're going to take 2 times the derivative of sine is cosine, plus sine times the derivative of 2, which is 0. Yes, that is a product rule, okay? And we should be able to do that one in our head and see what it works out to be. But I just wanted to do it kind of formally here, all right? So rewrite and simplify here. So when we rewrite, we're left with negative 2x sine of x plus 2 cosine of x minus 2 cosine of x. Notice the 2 cosine of x and the minus 2 cosine of x will cancel. So our final derivative is y prime is negative 2x sine of x. All right. Let's go over the quotient rule. All right. Quotient is if we're dividing two functions. So if we have f of x divided by g of x, and we need to take the derivative of it. All right. So the best way I can remember is low d high minus high d low all over low low. So what does that mean? Low is the denominator, high is the numerator. So I'm going to re-say that one more time. Low d high minus high d low all over low low. So low, which is g of x, d high, which is the derivative of f of x. So that's why we have g of x times f prime of x, minus high, which is the numerator, f of x, d low, the derivative of g of x, so we have f of x, g prime of x, all over low low, which means g of x times g of x squared. Okay? So try to remember that. It's always helped me. I've remembered that since, I originally took this course a long, long time ago. But low d high minus high d low all over low low. It has been a while since I was in high school, so I do remember my teacher teaching me that one, so I wanted to share that with you and make sure that kind of sticks with you. All right, low d high minus high d low all over low low. So as long as you equate high with the numerator and low with the denominator, you should be good there. All right, so let's do this. We're going to find the derivative of y equals 5x minus 2 divided by x squared plus 1. So we're always going to apply the quotient rule whenever we have some sort of division or fraction type scenario here, okay? So low, x squared plus 1, d high. So we're going to take the derivative of 5x minus 2 minus high, which is 5x minus 2, d low, the derivative of x squared plus 1, all over low, low, so x squared plus 1 squared. Alright, so when we do that, we get x squared plus 1 times the derivative of 5x minus 2 is 5 minus 0, which is 5. Okay, minus 5x minus 2 times the derivative of x squared plus 1. The derivative of x squared plus 1 is 2x plus 0, which is 2x. Okay, so we're left with this term here. And then we have to simplify the numerator down. So we're going to distribute the 5 to the x squared plus 1, and we're going to distribute the 2x to the 5x minus 2. There's not much we're going to do with the denominator right now. So when we distribute all that through, we have 5x squared plus 5 minus 10x squared minus 4x. Now you got to be careful with that minus that's hanging out in the numerator in the middle there. Eventually that has to affect each term. So that negative or that minus is going to distribute to the 10x squared, and it's going to distribute to the minus 4x. So that minus 4x will become positive. The 10x squared will become negative when we do this. Okay, so it's very imperative that you do that, and then we simplify everything down. So we end up with negative 5x squared plus 4x plus 5 divided by the quantity of x squared plus 1 quantity squared. Alright, let's look at another example here. We want to find the equation of the tangent line to the graph of f of x equals 3 minus 1 over x divided by x plus 5 at the point negative 1, 1. Okay, so what we must do to find the tangent line is we have to find the slope first, then we have to evaluate the slope, and then we have to use point slope. So there's 3 steps that we have to do there. We're going to find the slope of the equation, we're going to evaluate the slope at the given point, and then we're going to use point slope to find the equation of the tangent line. Okay, so this is kind of a rough, division problem here. So what we're going to do is we are going to simplify it before we apply the quotient rule. You can go right at it from this. It's just going to be a little bit more messier because you got to do the quotient rule twice, and when you have that 1 over x. Okay, so we can multiply by 1 in the form of x over x. So I'm going to take the original function and multiply it by x over x. That will clear my denominator of the 1 over x. Okay, so when you do that, you end up getting 3x minus 1 divided by x squared plus 5x. Alright, so the x in the numerator will distribute to the 3, and it'll distribute to the 1 over x. And when you distribute it to the 1 over x, the x's will cancel. Okay, and then in the denominator, it just distributes to x and the 5, so that's where the x squared plus 5 come in. Now we can apply the quotient rule to 3x minus 1 divided by x squared plus 5x. Okay, so low d high minus high d low all over low, low. So the low term, which is x squared plus 5x, times the derivative of the high term, so we're going to take the derivative of 3x minus 1, which is 3, minus high 3x minus 1 times the derivative of the low term, so the derivative of x squared plus 5x is 2x plus 5, and then all divided by low, low, so x squared plus 5x squared. So low d high minus high d low all over low, low. Now we're going to distribute to the 3 to the first term, alright, and then we're going to FOIL binomial multiplication or box method to the second 2 terms there. So when we do all that, we're going to get 3x squared plus 15x minus, notice how I still have that whole quantity, 6x squared plus 13x minus 5. I still have that all in parentheses because that minus sign in front of the 6x squared has to distribute to each term. So it's actually going to be minus 6x squared minus 13x plus 5 in the numerator. So that's going to distribute through. And when you do all of that, you're going to simplify your numerator down to negative 3x squared plus 2x plus 5, all divided by x squared plus 5x quantity squared. So that's our derivative. We found the derivative of that original function using the quotient rule. Now the next step is, since we want to find the equation of the tangent line at negative 1, 1, we have to evaluate the derivative at negative 1. Okay, because that's the slope. The derivative of the function is the slope of the function. We're going to evaluate it at that specific point. So we're going to substitute in negative 1 for x. When we substitute negative 1 in for x, we get 0. So our slope for the equation of the tangent line here is going to be 0. Then we need to use point slope to find the equation of the tangent line. So if you remember point slope, it's y minus y1 equals m times x minus x1. All right, and we know that y1 is 1, x1 is negative 1. That was the point given at the beginning. And we calculated the slope to be 0. All right, so we substitute those values in. And lo and behold, the equation of the tangent line is just going to be y equals 1. All right, so hopefully that helps. That's, as kind of involved as one of those gets. All right, let's take a look at some derivatives of some other trigonometric functions. Okay, and I'm going to do more examples of these in class lecture, not necessarily on this online lecture. Okay, but just know how to take them. So the derivative of tangent is secant squared x. All right, the derivative of secant x is secant x tangent x. All right, and remember I told you earlier when we were doing the derivative of cosine, the derivative of all the cos is always negative. Always negative. So the derivative of cotangent is negative cosecant squared x. And the derivative of cosecant x is negative cosecant x cotangent x. So just like the derivative of cosine, right, is minus the sine. The derivative of all the cos will always be negative. So that's a rule of thumb that you can always kind of pay attention to when you do this. So let's just do a quick example. If I give you the function y equals x minus tangent x, you would tell me the derivative dy dx is the derivative of x is 1 minus the derivative of tangent x is secant squared x. So it would be 1 minus secant squared x. Okay. Now, if we look at example B, we have x secant x. That's a product rule. Got to remember that's a product rule. First times the derivative of the second plus second times the derivative of the first. So when we do this, it's x times the derivative of secant, which is secant x tangent x, plus secant x times the derivative of x, which is 1. All right, so the final solution for this, okay, we would have secant x times 1 plus x tangent x. That's if we factor that out, okay? So that's where all that comes from. All right, so this is just kind of rounding out. You can kind of see the different amount of work. Some of these are the examples we did. Most of these are, but some of these are just examples I'm going to do on the board during the live lecture as well. So just so you know, but it's kind of like making sure that you're doing the work. And the calculus piece up front, that's the fairly easy part. It's the algebra, combining all the like terms and making sure that we distribute negatives correctly and that we FOIL and all that stuff out right. That's kind of the biggie on that piece, okay? So just know, and then make sure that you give the most simplified answer. All right, let's start talking about higher order derivatives. Higher order derivatives. So we know that when we have a function, and I give you a function, and I tell you it's s of t, that's called the position function. All right, so this will really apply to physics and things like that later on when you have to take those. So s of t, that's the position function. Then I might ask you to find velocity. Velocity is found by taking the